Python Numpy linear algebra. First, we are going to solve and system of linear equation using Numpy array. Suppose we want to solve and a system of linear equations at twice x plus y plus z is equal to 5. Then next equation is x plus 2y plus z is equal to 6. X plus y plus twice z is equal to 7. Then first of all we write the given system in matrix form as ax is equal to b. Ax is equal to b. So if we write this system into a matrix form, we get 2 1 1 1 2 1 1 1 2 into xyz equal to 5 6 7. And then you can apply a various techniques to solve or to find a value of xyz. The first technique is, if this is a non-singular matrix, then that is determinant is not equal to 0, then you can apply x is equal to a inverse b technique, or you can reduce this matrix to a row echelon form, or that is you can apply a Gauss elimination method or Gauss-Jordan elimination method. Now since we are going to use a Python here, so if you apply a solve AB, you will get the list of solution or containing the value of x, y, z in Python. For example, if we first of all want to import numpy as numpy as np, and then from numpy dot want to import the linear algebra file. So numpy dot linear algebra file. Okay, from numpy dot linear algebra import all the standard function. So for star, then we want to write a matrix A. So what is the A here? A is equal to 2 1 1 1 2 1 1 1 2. So A is equal to np dot array. Since we pass the for this array function, we are going to pass here list having shape 3 by 3. So here it is what 2 1 1 2 1 1. Then next is 1 2 1, and next is 1 1 2. Next we want to write the b, which is equal to again np dot array, and it is equal to what is the b here? Matrix B is 5 6 7. Matrix B is 5 6 7. Now here we are going to use, if you write here print solve AB, you will get the list of solution containing the value of x, y, z. So here the 0.5 is x, solution of x, that is x is 1 by 2, here 3 by 2, and this is 5 by 2. Okay, so that is x is 0.5, y is 1.5, z is 2.5. You can also write this as, if you write here x instead of print, if you write here x y z equal to solve AB, then the and if you write here print x is equal to x, next y is equal to, see here we want some space, okay, then next y is equal to y, and z is equal to z. Then we get the value of, this is x, y, and z. you can check here. This is what x, y, z. X is 0.499, that is it is 0.5, y is 1.5, z is what 2.5. so this is what x, y, z. So you can apply. If it is a singular matrix, you will get some error, that is if it has a given system has infinitely many solutions, that is if you write the matrix, say suppose you write a system of equation twice x plus twice y equal to 4 and x plus y is equal to say 8. Now this system has infinitely many solution. Okay, one sorry, two, sorry, here, right here, 2 x plus y is equal to. So this system has infinitely many solutions, that is if we write a matrix A here 2 2 1 1, this matrix is what singular matrix, since its determinant is 0. The determinant is 0, that is if you come if you evaluate this determinant here, this is equal to what, 2 minus 2 is equal to 0. And such a equation if you write in Python, it may give an error, that is your, if you want to apply this solve command, then there is an error, that is first if you write here 2, then here the next row is 1, and here if you write 4 2, and if you write here print solve AB, print solve AB, sorry, solve AB, then you can see here the matrix is what, singular matrix error. This is what singular matrix, because the determinant of this matrix is what, 0. Now to evaluate a determinant, you just write here, suppose you want to evaluate the determinant of this matrix, say this is the A matrix. A is equal to 2 1 1, A is equal to, say here 2 1 1, 1 2 1 and 1 1 2. Now we know that to evaluate the value of this determinant is equal to the value of this matrix, the determinant of A is equal to 2 times 2 1 1 2 minus 1 times 1 1 1 2 plus 1 times 1 2 1 1, that is 2 times the determinant of this here, this determinant of this 2 by 2 matrix. Then for minus 1 we take 1 1 1 2, and for 1 we take this determinant, 2 by 2 determinant. So this is equal to 2 times 4 minus 1 times 2 minus 1 plus 1 times 1 minus 2. So if you try to evaluate this, we get 2 times 3 minus 1, 2 minus 1 is 1, plus 1 times 1 minus 2 is minus 1. So this is 6 minus 1 minus 1, so this is equal to 4. So the value of the determinant is equal to 4. Now to evaluate this determinant in Python, you just write here A is equal to, okay, right here we are going to write create a matrix using Numpy array. So np array 2 1 1, then 1 2 1, and then 1 1 2. And if we want to evaluate the determinant of this matrix, then just write down here print determinant of A. So if you write here, you get sorry, what the missing, where does not, closing parenthesis not matching. Okay, here is an error. So now if you evaluate, it is what, 3.999, that is, it is what, 4. So you can check here, the value of determinant is what, 4. This is what 3.99 means, what, it is equal to 4. Now if we write here the previous matrix, say here 2 2 and 2 2 and 1 1, the value of this matrix is equal to 0. it is a singular matrix. If you try to evaluate, the value of this matrix is what? 0 0. So you can evaluate determinant of matrix. Next, if A is the given matrix, A is equal to 1 2 3 4 5 6 7 8 9, and if we write print here, if you want to print here diagonal entries, then just you can write a print diagonal of DIAG by using the command DIAG of A. DIAG of A, you will get all the diagonal entries of the given matrix. So here this is the matrix. A is equal to 1 2 3, then 4 5 6 and 7 8 9. Okay, and if we write print DIAG of A, DIAG has no meaning. Sorry, just write np dot DIAG, and you will get what is these are the diagonal elements of the matrix, this matrix A. So this is the first diagonal entries is 1, then 5 and 9. So you will get the diagonal entries by using np dot diagonal of A. Next, if A is the given matrix, say if you want to determine inverse of the given matrix here, say the inverse, this is what non-singular matrix, and if you want to determine inverse of this matrix, then just write down inverse of A command and you will get the inverse of the given matrix. So here A is equal to, if we write again 2 1 1 2 1 1, then 1 2 1 1 and 2 1 1 1, and if we write here inverse of A, Inv of A, and you will get singular matrix. It is 1 1 2. It is not a singular matrix. 1 1 2, and you can see here this is what the inverse of the given matrix A. So by using this command you can find inverse of the given matrix A. Now next we want to determine the you can also find a trace of the given matrix A. So what is the trace? We know that what is the trace of this matrix here. Suppose A is equal to 1 2 3 4. If we add the diagonal entries here, 1 plus 5 plus 9, we get the trace of this matrix. So it is equal to what? 15. So if we write again A is equal to here, suppose this is the matrix, and if we write here np dot, for to find a trace just write down command np dot trace of A, and you will get this trace is what? 6. That is the first 2. This is 2 plus 2. What is the trace of this matrix? The trace of this matrix is what? The matrix A is equal to, I am writing here, A is equal to 2 1 1 1 2 1 1 1 2. So the trace of this matrix is the addition of diagonal entries, which is equal to 2 plus 2 plus 2, which is equal to what? 6. So now next, all of we know that how to find an eigenvalue and eigenvector of a matrix. Suppose consider the 2 by 2 matrix. A is equal to, say A is equal to 3 1 2 4 3 1 2 4. This is a 2 by 2 matrix, and we want to determine eigenvalue of this matrix. Then consider the determinant A minus lambda I equal to 0. Then this implies 3 minus lambda 1 2 4 minus lambda is equal to what? 0. So if we simplify this determinant, then it is equal to 3 minus lambda into 4 minus lambda minus 2 equal to 0. So this is equal to 12 minus 3 lambda minus 4 lambda plus lambda square minus 2 is equal to 0. So this is equal to lambda square minus 7 lambda. 12 minus 2 is equal to plus 10 equal to 0. Now this is a quadratic equation in lambda. I want to determine two numbers is that the product is 10, addition is minus 7. So such numbers are lambda minus 3, lambda minus 2, lambda minus 2, lambda minus 2, lambda minus 5 is equal to what? 0. The 5 into 2, minus 5 into minus 2 is 10, and their addition is what? 7. So it is equal to lambda is equal to 2, lambda is equal to what? 5. So the what is eigenvalue here? 2 and 5. So in Numpy array also you can use a command EIGA to find eigenvalue of the given matrix. Say A is equal to np dot array, what is the matrix? It is equal to 3 1 2 4, 3 1 2 4, 3 1 2 4, and want to determine eigenvalues of this matrix. Just write down print EIG of A, and you will get the eigenvalue of the given matrix. It is what? 2 4, 2 5 eigenvalues. These are 2 5 eigenvalues, and this the next is what? Eigenvectors. So this is the first eigenvector of 2, eigenvalue of 2, and this is the second eigenvector of eigenvalue corresponding what? 5. So this way you can find eigenvalues and eigenvector of the given matrix. So next, okay, there is one more. You can find a product of two matrix by using this. Suppose A is equal to, say A is equal to 1 2 3 4, and B is equal to say 4 5 6 7. Then A dot B is equal to, that is A into B is equal to first row into first column. So this is equal to 4 plus say 12, 4 plus 12. Then first row into second column, so it is 5 plus 14. Then second row first column, so 12 plus 24, and second row second column, so this is 15 plus 27. So if we add this, it is equal to, this 4 plus 12, it is equal to 16. Then 5 plus 14 19, 12 plus 24 36, and this is 27, this is 37 plus 5 42. So the multiplication of this matrix is what? 42. Now in Numpy also you can evaluate the multiplication of matrix. So A is equal to np dot array, we are going to generate the first matrix is what? 1 2 3 4 and 4 5, 1 2 3 4. This is the first matrix. Similarly, matrix B is equal to np dot array, np dot array 4 5 6 7. So now to find product of two matrix, just write down the command. Okay, two different ways you can find a multiplication of this matrix. If you write here just print A into A dot B, you can write, then you will get a matrix say 16 19 36 and 43. So here, so you can check, sorry, 15 plus, something went wrong here, 15 plus, this is what, 15 28, here it is not 27, this is what, 28. So 28 plus 15, it is equal to what? 43. Now you can see 16 19 36 43. So 16 19 36 43. Or there is one more way, you can write it as A at the rate B. Then you can use this command also to find a multiplication of two matrices. Okay, so these are the two different command. By using this you can find a matrix multiplication. So trace determinant. Hope you understood this linear algebra concept. You can solve the system of linear equation if the given matrix by using solve command. If it is a non-singular matrix, then you can find a determinant of matrix, you can find a diagonal entries, you can find a trace of the matrix, you can also find eigenvalues and eigenvector of the given matrix, and you can find the product of two matrices. Thank you.